Okay, good morning, good afternoon, good evening, based on wherever you are. Welcome to second session of this online course on partial least square structural equation modeling using WarpPLS 7. I'm Dr. Mustafa Rasuli Manish from School of Hospitality, Tourism and Events, Taylor's University. In this session, actually, we will focus on higher order construct and the higher order measurements model. So I will try to cover some basic concept related to higher order construct specification and evaluation. Then we will go to software to see how we can perform this how we can create higher order construct in WarpPLS software and how we can evaluate higher order measurements model using different actually techniques, available techniques for higher order construct. I will try very quickly go through this basic concept. If you have any question about the concept later, after actually my presentation and showing the software, you can ask your question and we can go through your question. Higher order construct, the concept of higher order construct, actually they refer to a measurement model that has more than one dimension. Actually, a measurement model that we evaluate based on some dimensions. And these dimensions are evaluated or measured by some items. So actually, the higher order construct, the main construct measure indirectly by some items. Items and indicators measure dimension, and actually dimension are indicators or items of main construct. We have many examples from higher order construct. For example, when you measure perceived value, and perceived value has three dimensions, including functional value, social value, and emotional value. And these three dimensions are measured based on some items. So perceived value is considered a higher order or second order construct, but measured based on three dimensions and dimension measured by items. But we need to consider some important point when we are working with the higher order construct and when we want to include higher order construct in our framework. Actually, the most important point and actually criteria that we need to consider when we include higher order construct in our framework is supporting by theory and by literature. When we have a higher order construct, we cannot simply combine some construct, some variable in our framework and come out with a higher order construct. For example, combine some construct and give a name to these combination of constructs, say external factor, for example, or internal factors, and consider external factor or internal factor as a higher order construct, as a second order construct. Actually, this is not possible. If we want to establish a higher order construct, the first and the most important criteria to establish a higher order construct is supporting from measurement theory and supporting from literature. If you want to combine three dimensions of perceived value, functional, social, and emotional value to establish perceived value, we need support from literature and we need support from measurement theory to combine these three dimensions to establish perceived value. So this is first and most important thing and criteria that we need to consider when we when we include the higher order construct in our framework. Actually, only because of reducing the complexity of our framework is not possible to combine some variable and create a second order construct. Another thing that we need to consider when we when we include higher order construct in our framework is a structural level. Actually, we need to look back to our research objective, and our hypothesis that we are supposed to test to address our objective. If our objective refer to relationship between dimensions of second order construct and other variable involved in our framework, so we need to test relationship between dimensions and other construct, other variables. So again, it's not possible to establish higher order construct. If we establish higher order construct, it means we lose the relationship between dimensions and other variable in our framework. Okay, if our objective refer to relationship, refer to effect of second order construct and other variable, so it's fine. And we have support for measurement theory, we can establish higher order. But if our objective refer to relationship between dimensions and other variables, if we create higher order, actually we miss this hypothesis. We miss hypothesis for relationship between dimensions and dependent variable, right? So this is second point that we need to consider when we want to establish higher order construct. Actually, in other words, higher order construct, when we establish higher order construct, we consider measurement level. And our assessment is in measurement level, not structural level. So for second order construct, we don't consider any, we don't assess any hypothesis. All assessment of measurement, all assessment of higher order construct refer to measurement model. Relationship between items and dimension, first order, and relationship between first order and second order dimension and second order construct. So all these assessments fall under measurement model assessment, not structural model. But if you need this relationship between dimension and other variable in a structural level, so we should not establish higher order construct. So this is second point that we need to consider when we decide to higher order construct in our framework. Actually, for higher order construct, we have four main type of second order or higher order construct. But these can be more than these four common and main types. Okay, these main types are here we have these four main types of second order construct. The first is reflective type 1. Based on the study of Ringlet 2012, that they actually analyzed 25 models that include the higher order construct. They found 5 out of these 25 are reflective. So this is reflective. Reflective can be considered one of the common type of higher order construct. That in first level we have reflective construct and also dimension reflectively established second order. Another type of higher order construct that is most common type of higher order construct, and also in this study this type of second order or higher order is 15 out of 25. This type is reflective formative. Reflective formative means the nature of first layer or dimension of this second order construct are reflective. So items reflectively establish dimension, but dimensions formatively establish second order. Here, actually, I would like to add the reflective composite construct also. If we go to the literature and see this type of construct in the literature, most of the models actually that we have been as a reflective formative actually are reflective composite, but composite can fall under reflective, because formative under formative, in formative we have two types of formative: causal formative and composite formative. But there is a significant difference between causal formative and composite formative. In causal formative, we have error term in construct level, but in composite formative, we don't have error term, right? Okay, so when we have, for example, a few reflective dimension, go back to perceived value. We have perceived value with 3 dimensions, and these 3 dimensions of perceived value are measured reflectively. But these 3 dimensions actually measure different aspects, different angles of the perceived value. So these 3 dimensions, functional, social, and emotional value, formatively establish perceived value. But here we can see compositely. So they are composite dimension, because we know based on literature, when we have this type of second order, dimensions, most of time, dimensions actually cover all aspect and area that can establish our construct. So this can be difference between composite and formative. So for composite second order, actually we don't have error term most of time. We don't have error term in construct level, because we know we include all dimensions to measure this second order construct, this composite construct, right? So when we include all aspect, all dimension, all indicators to measure a formative construct, so this construct can be considered composite, right? And we don't have any missing part for error. Second type, second order construct. Third type is formative reflective. Actually, this type is very rare and almost impossible to happen, because when first layer are formative, first layer dimensions are formative, how second layer, these formative indicators establish 3 constructs, and how these 3 formative constructs, that the nature of items of each construct, each first order construct and dimension are different and from different perspectives. How these indicators and these dimension in second level can be formative, reflective. So this type of second order is very rare, and I don't know how this type of higher order construct can happen. So in this study also we can see out of 25 models is fall under formative reflective type. And the last type of second order is, or higher order is formative. So first layer items to measure dimension are formative, and the dimension also formatively establish the second order. Here also can say most of time should be composite and no error term in construct level. So we have these four main types of higher order construct, but there's something to think and actually food for our thinking. It seems that it's possible to have different types of first order, that these different types of first order establish, for example, formatively second order or reflectively second order, right? So this can be possible, especially if we don't use the traditional repeated indicator approach. If we don't use this one, we don't have any problem to include different types of dimensions in the first layer. And these different types of dimension actually can establish second order formatively or reflectively. For example, let's say the first LOC can be formative, second one can be reflective, and third one also reflective. And these three establish this HOC, this higher order, reflectively or formatively. So it's just something to think. But these four are four main types of higher order. Okay. There are some literature about assessment of higher order construct, especially the work of Becker et al. 2012 is one of the masterpieces in assessment of higher order construct. In this paper, actually, they focus on reflective formative, and they propose, based on the simulation, they propose some recommendation. For example, if we have formative in second layer, regardless of first layer, regardless of first order, so first order can be reflective or formative, they recommended to apply mode B for repeated indicator if you want to apply repeated indicator approach. So this is different with our traditional thinking, because in our traditional thinking for repeated indicator, we think always the nature of item in second level for repeated indicator should be consistent with first layer and dimension, right? So if dimension are reflective, repeated indicator in second order should be reflective. If dimension are formative, so repeated indicator in second order construct should be formative. But actually here, they suggest, based on their recommendations, based on nature of second level. So the relationship between dimension and second order, if it's formative, regardless of nature of dimension and first order construct, it's better to apply mode B and formative in second order construct for repeated indicator. So they actually provided some recommendation, and they checked some common mistake that, for example, with this is traditional thinking that if we use repeated indicator, all the number of indicator in each construct should be equal. But they confirmed that this is not the case. So the number of indicator can be different, and it's not actually compulsory to be equal. But overall, actually, they suggested the two-stage. Traditionally, for assessment of higher order construct, we have two main approach. One is repeated indicator, that we repeat indicator of the first layer, indicator of dimension on second order, and based on the nature of items in first layer. But based on Becker's work, if the second layer is formative, so we have to use mode B and prefer to use mode B for second order. Another method is the two-stage approach. Later in my example in software, I will show you how we can perform two-stage. But in two-stage approach, we actually, under two-stage, we have two different two-stage approaches, is embedded the two-stage and the disjoint two-stage. And for both two-stage methods, we, in first stage, we calculate a score of latent variable. We calculate score of dimensions, first order construct, and then we use this score in second level to establish, in second stage, to establish second order construct. So we use the score of latent variable to establish second order in second stage, stage 2. So this is the concept of two-stage approach. But how we establish the second order and how we calculate latent variable score is different a bit in the embedded to a stage and the disjoint to a stage methods. But actually, for repeated indicators, literature showed several problem and difficulties when we apply a repeated indicator method. One of the most common and actually the worst situation is when we have a formative construct, when we have a formative second order construct, reflective formative or formative second order construct as a DV. So when we have this DV as a second order formative construct, if we use repeated indicator method, so if we add any other variable in this framework, here, Y2 is second order and is formative, right? So we use repeated indicator here. And you can see if you include Y1 as an independent variable, if you apply a repeated indicator, the path coefficient or beta coefficient for the effect of Y1, Y2 always will be 0. Because actually the whole variance of Y2 explained by this dimension, explained by this 3 dimension of this second order construct. So there is no room, there is no place for other variable. So if you include any variable, any independent variable to this framework, path coefficient or beta coefficient will be 0. So to avoid this problem, if especially our DV is second order formative construct, literature recommend and also this paper recommend to apply to a stage. Also, the several other problems has been mentioned by literature for application of repeated indicator. So, especially recent literature suggests to apply to a stage compared to, regardless of the type of to a stage, you can apply embedded to a stage or disjoint to a stage compared to a repeated indicator method. This paper published by Marco Zartset and his colleague is a good paper on a specification and actually evaluation of higher order construct. In this paper, they presented these three methods. They discuss repeated indicator, and also they discuss embedded and disjoint two-stage approach, and the difference between a result and the process of assessment of each method. But before going to before going to application of software and show how we can create second order in WarpPLS, one important things for assessment of second order is when we have higher order construct, when we have second order construct in our framework, and we use two-stage or repeated indicators. Actually, we need to assess measurement model in two different stages, 2 times. First, assess measurement model of all first order construct, including first order construct or dimensions of second order and other first order construct in our framework. So let's say we have one second order construct with 3 dimensions and 4 more construct in our framework. So in first stage, we need to assess dimension of this second order 3 construct and other 4 construct in our framework. So we need to assess 7 construct based on the nature of measurement model of 7 construct, based on the nature of measurement model of these constructs. If some of the constructs, some of the dimension or first order construct are reflective, so we need to apply reflective quality criteria to assess reliability and validity to assess measurement model. If they are formative, we need to apply suitable criteria to assess formative measurement model. So in first step, we need to assess all first order construct, all lower order construct. And then in second stage, when we establish second order, we need to assess and we need to report measurement model of second order with other construct in our framework, right? So you ask why in first stage we assess we assess all construct involved, and why we need to assess again in second stage when we establish second order. The main reason for this one is because of evaluation of discriminant validity. Because in first stage, we assess discriminant validity for dimensions and other construct involved in the framework. But in second level, in second stage, we have to assess discriminant validity for this new construct. This second order, actually the second order is a new construct in our framework and other variable involved. This is one point. Another point, actually, when we establish second order, because all parameters using PLS are affected by nomenological relationship between variable. So the parameters for measurement model, for reliability, validity, may be change a bit after we establish second order. So we have to assess measurement model and report result of assessment of measurement model in these 2 different stages, in first stage and second stage. Okay. Okay. Last week, I explained how we can install software and how we can activate a trial version or license if we have, and how we can create a model and perform some basic analysis to assess measurement model and structure. Actually, to create a higher order construct and show you assessment of higher order, I will repeat these steps. So we can go through these 5 steps. As I explained before, for WarpPLS, we have 5 main steps and simple steps to create model and to perform analysis. We need to start from step 1. So if we click on step one, we need to open project file or create project file. So if we have a project file that we already created, only we can click on open project file and open available file and work on it. But if we don't have and we want to create new project file, so we need to click on create project file. So if we click on create project file, I'm going to this workshop. Okay, here I create this project file, online course. And click on it. Okay, now we can go to step 2. You can follow me. You can see the steps that I'm doing.
Yes, Prof.
Okay, so now we can go to step 2. In step 2, we need to read the file, but in WarpPLS, we can actually use different types of file. We can use Excel file, we can use a tab delimited file or a comma delimited file. So if we click on read from file, and also we can read from clipboard. If we have a file, we can copy and paste here and use this icon read from clipboard. But now I want to read from a dataset file. So you can go to your file because in this folder, my file is in this folder. But when I go to this folder, nothing shown here because the extension here is only text file, but we can change the extension and we can use our dataset for webinar. Click.
Sorry, Prof. I think your screen is freeze.
Screen is freeze. Now you cannot see. Okay.
Yeah, we can see.
Okay. You can see data file here. You have to see this this window. View accept raw data. Does the data look correct? Right. You can see this one.
Yes.
Okay. So
We can see it, Prof.
you can.
Yes.
Okay. So when you come here, you can check your data file here. This is your raw data. And if it is okay and looks okay, you can click on yes and go for step 3. In a step 3, we do some pre-processed data. We can do actually the check for missing value and replace missing value, use the mean replacement. And also, for missing value, you can change the method. WarpPLS actually provide a few methods for missing value imputation. And check also for some other criteria like checking for zero variance and identical column, and create standardized data. And when you click on OK, you can see your standardized data here. So in this step also you can check your data. If nothing wrong, you can go for step 4. Actually, in step 4, define SEM model. When you click on SEM model, this window will be appear. And here you can create your framework. Okay, in this framework, actually, we have four independent variable and one higher order construct and one dependent variable or exogenous variable, right? So I will create for this same as the model that we used last week. So this first one is community attachment, and community attachment has 4.
Sorry, Prof. I think your screen freeze again.
What about now?
Still
Now
the
you
same.
see.
Same.
Same.
Still same.
Okay, let me stop share and share again. What about now?
No, it's okay.
Yes.
Yeah, it's
Okay.
okay. It's showing.
Okay, so we have community attachment. Then we can create a second independent variable is environmental attitude, our framework. And here we have 2 boxes. One box include all your indicators, and another box you need to transfer indicator of this construct. So for EA, we have 3 indicator. As before I explained here, in this step, you can identify, you can actually click on reflective and formative based on the nature of your construct. So we keep reflective because our construct are reflective for independent variable. So we have EA here, environmental attitude, and the last one, we only include the cultural attitude and transfer these 3 for cultural attitude. So we have 3 independent variable here. But for a second order, we have resident perception, and resident perception include 3 dimensions: economic perception, social perception, and environmental perception. So we create 3 dimensions of the resident perception first. So we click on the repeat same step, resident perception, economic. So, okay, we have 4 indicators for resident perception, economic resident perception, economic dimension, and save it. Second one is resident perception, social dimension, and all are reflective. First order construct or reflective. So we keep reflective in this step. Okay. Here you can see inside the box, inside the construct, you can see R. So R refer to reflective, and this number is number of indicator. So for example, the resident perception economic perspective has 4 items, and items are reflective. But if we change to formative, F will be appear here. So F means formative construct. So we create the third one. Third one is the resident perception and environmental perception. Okay. sorry. We need to edit the name. This one is social. Okay. And the new one is resident perception, environmental. Okay. So we have these 3 dimensions, and our dependent variable or last layer of framework is support for tourism development. So we have support here and support as 5 indicators. Okay. Okay. So now we have our framework, including one second order construct. So these 3 are dimension of second order construct. 3 IV and 1 PV, right?
Dependent.
Okay. Okay. When we want to apply, as we discussed, we have 3 main methods for creating or to establish second order construct, right? Repeated indicator, 2-stage embedded, and disjoint, right? Why we have these 3? Because actually in PLS, in a traditional algorithm of PLS, we need nomonological relationship. We need nomonological relationship between all constructs that we will be able to perform analysis, right? So without any relationship, without relationship between constructs, even one missing relationship, we are not able to perform analysis, right? But actually, in WarpPLS, addition to traditional mode A and mode B, we have some other algorithm for outer model that give this capability to model, and actually we are able to perform analysis without relationship between constructs. So if we use WarpPLS and this specific outer model algorithm, doesn't matter we apply embedded or disjoint to a stage. We can create even without any relationship between constructs. Okay, so for example here, we don't have any relationship between construct now. But if we save model and close, okay, here we have the result. We can see the result for this one. We don't have add coefficient. We have the result of loading, cross loading. We have the result of quality criteria, composite reliability, Cornbus alpha, average variance extracted, full collinearity. But we don't have the Q square and we don't have R square because we don't have any relationship. But we have criteria for measurement model, right? Also in this step, we can get, okay, if we decide to go with this outer model algorithm, this outer model algorithm that is able to able to assess measurement model and create quality criteria for measurement model is PLS, show you, it's PLS regression outer model. So in PLS regression outer model, we don't need the relationship between constructs. Okay. if we click here, you can see many different outer model algorithm. Mode A and mode B, mode M, A basic, B basic, all needs a relationship between constructs. And without this relationship is not possible. Only this PLS regression can perform and can create quality criteria without any relationship between constructs, right? So if you choose PLS regression, so it's possible to, in this stage, stage 1, you are able to perform analysis and assess measurement model in this stage. So you can get all criteria that you need for assessment of measurement model here. Okay, all constructs are reflective. So we can check, we can report loading. We can report other criteria, composite reliability for assessment of construct reliability, and also convergent validity, and also criteria for assessment of discriminant validity. Discriminant validity, we can get Cornell-Larker criterion from here, and also we can get, last week I showed you, if we go to explore, we can get discriminant validity criteria, different criteria here. It's this one is AV, square root of AV and correlation, Cornell-Larker criterion. This one is cross-loading. This one is full collinearity. That last week we discussed. Full collinearity can be very good criteria, especially when we have combination of formative and reflective construct, and also HTMT, heterotrait monotrait ratio you can get here, and also inferential statistic or confidence interval for assessment of HTMT, compare HTMT to 1. So without relationship between construct, you can get all these quality criteria for assessment of measurement model. So in first stage, you have to report all these criteria for these dimensions, dimension of second order, and also independent variable and other variable involved in our frame, right? Okay. So now we want to go for second stage in WarpPLS. We want to actually get the score of these 3 dimension and establish second order construct. In WarpPLS, we don't need to get this score and transfer to our data set and again read new data set to get this latent variable score and use in second step. WarpPLS, actually, we can create latent variable score as a new indicator and use in our framework. Okay. After this stage, if you go to modify, option here, there are 2 options here. Add 1 or more latent variable score as a new standardized indicator, or in one run, you can add all latent variable score. But we don't need this one because only we need the score of these 3 dimensions. So we click on this option and get score of each dimension one by one. Okay, then when we click on this, okay, latent variable to be added. Which latent variable actually we want to add to our as a new indicator? So we want to add the economic perception. So click on economic perception. IV RP echo is latent variable score of this construct, this dimension. So if we click on add, okay. So here, this is a list of indicators. Here we have this new indicator. Okay, now second one, resident perception social, click. So we have resident perception social perspective here and environmental, click. Okay, so now we have these three new indicators, latent variable, score of these dimensions. So just close window. Now we actually added these three dimension, score of this three dimension as a new indicator in our set of indicators. So if you to do any changes in your framework, you need to go back to a step 4. Any changes should be done, should happen in step 4. So you need to click on proceed to a step 4, and you will come to your framework here and this step. Okay, so now we want to create a new variable, and this variable is second order construct. Okay, click on create. This second order construct is resident perception, but second order. Okay. Okay, what's the indicator of this? What's the item of this second order? Okay, here we have three new items, three new indicators that are latent variable, score of these three dimensions. So we need to click on these three. But these three dimensions establish resident perception formatively. So we need to change to formative. Okay, and say, now we have this second order construct. And this second order construct, you can see F here. F refer to formative, and the 3 refer to number of indicators. So this second order construct has 3 indicators, 3 items that formatively establish this construct. Now we can create our link and the structural relationship. So to create link, we need to click on direct link option and click on first and start and end the construct. So we have these 3 and this one. Okay, but what about this 3? We don't need these 3 dimensions anymore, right? So we only delete these 3 dimensions. Because actually, if we keep these 3 dimensions, our model will create a high multiple linearity, right? Because this construct is a second construct including these 3 dimensions. So don't need to keep this 3 dimension and remove it. This one is, this method actually is very similar to disjoint to a stage approach. But in WarpPLS, we don't need to go for embedded to a stage approach, because in first stage, in embedded, in first stage, we include second order using repeated indicator, right? But here we don't need to create, because actually we don't need any relationship to get the score of latent variable. Okay, so we create our structural model and save model and close. And go to step 5. Okay. So now you have result of measurement model and structural model. When you include the second order, you need to assess measurement model for this second order and other first order construct involved in your framework. But this second order is formative. For assessment of formative, we have to check VIF. We have to check multicollinearity between items using VIF, and we need to check significance of weight, right? So first, we check these two criteria for the second order construct. If you click on view, you can see here the result of indicator weight. Indicator weights. So if you click on indicator weight, WarpPLS provide weight for all construct regardless of nature of construct. So you can see weight for also reflective construct, but the weight for reflective construct is not useful for assessment of measurement model. So directly go to last part. So this is weight for second order, and these three indicators: economic perception, social perception, and environmental perception. So the weights are 0.406, 0.402, and 0.428. Here you can see the nature of construct. So this is formative. You can get the standard error, all information that you need for assessment of formative construct, formative measurement model you can get from here. So you can get the standard error, p-value. So all these three weights are significant. And also here you can get VIF, multicollinearity for these three items is 1.43, 1.41, and 1.58. So all VIF or full collinearity are acceptable, and VIF is lower than 5 and lower than 3.3 and even lower than 2.5. Actually, for reflective construct, the literature, the threshold for VIF is recommended 2.5, not 5. But also some literature suggested 5 for VIF. So if VIF is lower than 5, or much better to be lower than 2.5, you can check weight and significance of weight. So you can get all these criteria from here. So measurement model of formative second order is acceptable. And also you need to check the other criteria for reflective construct or other first order construct, reflective or formative, right? So we have 4 more reflective construct. So you can check loading, you can check latent variable coefficient, and the CR, Combat alpha, and ADE for reflective construct. Full collinearity now is very useful to assess actually discriminant validity. Because now in your framework, you have one formative construct. And available criteria so far cannot assess discriminant validity for formative construct, right? So in second stage, when we want to assess discriminant validity, only we can assess discriminant validity for these 4 reflective constructs. And we check based on formal article or HTML. But what about this formative construct? And this is a high possibility that formative construct has similarity with other involved construct in our framework. So we need to make sure about discriminant validity and establish discriminant validity in second stage. So here we can check we can check full collinearity. And this full collinearity, here we have full collinearity for second order construct and formative, right? And the other reflective construct. So you can see second order construct and all the reflective construct, the full collinearity is lower than 3.3. And 3.3 is the threshold for acceptable full collinearity. So based on this, you can make sure about discriminant validity, and actually you can establish discriminant validity when you have second order formative construct. So, and then we can actually assess structural model. And the structural model, here you can see only is the relationship between other construct and second order. Relationship between first order and other construct cannot be considered and they actually cannot be assessed in a structural level, right? So if we actually use this outer model algorithm available in WarpPLS, but if we want to stick to traditional algorithm, mode A or mode B, so we have to change let me go to okay. If we want to stick to traditional, for example, here mode A and mode B, mode M in WarpPLS is for some cases that we have combination of reflective and formative. Mode M means mode A is applied for reflective and mode B is applied for formative, right? So if we click on mode M, and proceed to define, okay, delete this one, and again create 3 first order, okay. So we have now these 3, okay. If you want to use this joint, no need to create second order, but if we want to use embedded, we need to create second order using repeated indicator. I'm just going with this joint. So you need to connect this variable to first one, second one, and also third one. and create this 3-dimension to TV. So this is disjoint to a stage when we want to actually use mode A or mode B outer model algorithm. So when we create this one, we repeat this same process and click on step 5. So here you have information. So you need to use the criteria for assessment of measurement model. You need to check loading and also latent variable coefficient, composite reliability, Cronbach alpha, average variance extracted, and you can go to this step, explore for discriminant validity criteria. So you need to report all criteria for first stage, and then repeat same process to create new variable, add one or more latent variable. So okay, so we have now economy, we have social, and we have environmental. Okay, so here, but here you can see two set of latent variable score. One is from previous round, so keep here, and another one is new indicator based on this round, and the data from latent variable from this joint method. So same, we have to go to this step, and now we can delete all these 3 dimensions, right? Because we don't need this dimension. So when delete, only we need to create resident perception as a second order construct. And here is 3 indicator that we have, 3 new indicator and formative. Okay, so we need to follow same steps. Okay, and the run model. Okay, and report the result of measurements model and structural. So this is the way that we actually apply two-stage approach with the different outer model algorithm in WarpPLS. Okay, we have more time for a question today. So now we can go to Q&A part. Okay, any question or comment? Okay, let me check chat box. Last week, I showed you the only paper so far is our paper that we presented in PLS-17 conference in Macau, and they got some feedback from scholar there. And actually, we did a simulation in that paper. So only available reference for using discriminant value, for using full collinearity for discriminant validity is our paper. Actually, now we are working in another paper, and we are doing a simulation with the bigger data set. Hopefully, if we can publish this paper, will be another reference for using full. So I answered this question.
Sorry, Prof. Can we read the paper? What is the title?
And the paper, okay, the title of paper is, okay, let me share here. Going to my profile, see if I can find here. And title of paper is about food collinearity, but let me give you the citation. Okay, this is the paper.
Okay, thank you.
And the paper is available in ResearchGate, so you can refer to this paper if you want to use it. And pray for us to publish paper with the bigger simulation study to a good journal, so you can refer and cite. Okay.
Okay, thank you.
Okay. Any other question?
Yes, Prof, can I ask?
Hello, sir.
Yes, yes, please.
I'm Dr. Sandeep Singh from India. Sir, I have a question regarding the WARP algorithm, which we have basically used in the while we are conducting our search. So, is there any specification which type of the algorithm we will use? Like generally in the module, I have gone through this. Like you should have to use the WARP 3 for the purpose of when there is a no specification to use whether you are testing linear or non-linear relationship. So what do you say on this, sir? What is your opinion on it? Thank you.
VAP3 is for S-curve relationship and more the most complicated algorithm for relationship. So is S-curve nonlinear. VAP2 is U-curve or J-curve nonlinear. So using VAP2 or VAP3 depends on your area of your research. For example, if you are working in the finance and the previous study actually detected the J-curve relationship or U-curve relationship between some variable. So it's possibility for U-curve or J-curve, so you can choose the VAR2. If you want to explore some relationship that is supposed to be S-curve and more complicated relationship, so you can apply VAR3. But one very important things about nonlinear algorithm in WarpPLS, if you choose VAR3, so this is the reason that VAR3 is default in WarpPLS. If you choose WarpPLS, based on the pattern of your data, software will detect the best curve or line for relationship based on your data. So it means if your data, the pattern of your data is linear, if you choose VAR3, also linear will be detected. If it's U-curve or J-curve, so VAR2 or J-curve or U-curve will be detected. But if it's something similar to S-curve, so S-curve will be detected the curve for the relationship between constraints.
Sir, if we
If
have a
if
no,
I summarize, if I want to summarize, one is based on literature. Second, if you choose VARP3, software actually can help to identify, to detect the best care for relationship. But as I explained last week, if you choose nonlinear pattern, if you choose nonlinear algorithm, your interpretation should be based on plot.
okay.
Interpretation is not easy like a linear relationship, right? So you need to look at the plot and interpret your result.
Sir, I totally agree with you. The just thing is that okay, I think the purpose of the model fit is to give the best R square. So generally, if there is a default warp 3, so I feel that is, I think, the better, because that are explaining the most of the, they are reducing the error and explaining the more. So generally, when we assume that okay, every relationship is a linear. So I don't think so. Okay, we should have to assume every relationship is a linear. Generally, what we have to do, we generally just assume every relationship is the linear, but when you apply the warp, you will find out what actually model is fit and what type the curve we are getting. So I think that is my personal opinion, hopefully I will be wrong. I think that is the best approach uh, to use the warp 3 rather than to the uh, linear or any other function, because I think the
Why
best
you
the object.
why you hope your idea is wrong?
Sir, just because because of the literature we have gone through, we always assume every relationship is a linear, but generally thing is not. When you have see that scattered plot on the data, you will see the real picture of the data.
Yeah.
So that's why I'm saying generally I have done one project on the WarpPLS. It's the second time I'm listening you. So that's why I have a quite interest in this Warp 3, sorry, in WarpPLS software. So
Okay.
you are the kind of person who can give me the information. There is
Thank
nobody
you.
in the world who can with
Thank
whom
you.
I can discuss these things. So you are the one of the best person I have found
Thank you. Thank you.
who
Thank
are
you for your
taking
kind word.
initiative. So this is my submission. So that's I think this, as I say, this is a common sense. You should have to find the best fit in the data rather than to assume that any relationship is linear. What do you say, sir, on
When we apply VARP3, the best fitted curve is presented by software and detected by software. But my suggestion is we can apply VARP3 if we don't have very strong support from literature, right?
Yes, exactly.
We can apply VARP3 and look at the plot and
Yes,
interpret based on plot. This can be some post hoc analysis, right?
yes,
Post hoc
yes.
analysis. Also, we can actually run both linear and non-linear, and the report result of linear if traditional in the literature recommended linear relationship, but the assessment of model using non-linear can be a post hoc analysis and can be used for recommendation for future studies.
Yes, sir.
So
That's,
this can be the actually the you apply a traditional one, but using this nonlinear, you can provide the recommendation for future study and also get actually the richer insight.
sir, I would like to share one more experience if you allow me to give me 1 minute more. If you allow me, otherwise I'm not taking too much time of you. Can I
Okay.
speak?
Okay, 1 minute is fine because I want to see others if they have any other question. Okay, go ahead.
So, sir,
One
one
minute should be okay.
so one thing I found best in the warp is you can also by applying the warp 3, or yeah, you can the other warp 2 or warp other warp algorithms, you can also find the unobserved heterogeneity from the data.
Yes,
So
exactly,
that
exactly.
can be that can also be a good scope of the research for the future. So
Exactly. VAR3, one of the most important, last week I explained this one very briefly. VAR3 algorithm is when, because WarpPLS provide plot and segment
exactly.
plot. So based on segmentation plot, actually we can see unobserved heterogeneity. And this
So
observed heterogeneity very easily and clearly can be
yes,
detected
yes,
and
you
reported
can
in
see very
RPL.
clearly detect the unobserved heterogeneity,
Yes.
and even this is the beauty of this software. What I found,
Yeah.
but I have used also Smart
There are
PLS at
many
ANCO.
beauties in this software.
Ah, yes, yes, yes. So you know better than me, sir. Sorry for that. Thank you very much.
Okay. Thank you. Thank you for sharing your insight and experiences.
Thank you very much, sir. Okay.
Okay. Any other question?
Sir, can I ask?
Yes.
I'm Yasir Rasool, PhD scholar from Pakistan. Thank you so
Can you
much.
speak a bit louder? Cannot hear.
Yes, can you hear me now?
Yeah, it's better, but a bit louder would be better.
Okay. I hope this time it's gonna be audible for you. Is it now? Is it okay
Yes,
now?
yes, yes, yes.
Okay. My question relates to a bit basic one. Okay. Question is, which one of the approaches is most suitable for all four types of the second order or higher order construct?
Based on my experience, disjoint approach, disjoint to a stage approach.
And I would like to know the reason, a brief explanation why one would prefer this approach over others.
Preference of this approach compared to repeated indicator is very obvious. So repeated indicator has many problems when we apply. But compared to embedded approach, actually when we apply embedded approach in first stage, we include we include second order with the repeated indicator, right? We don't assess second order in first stage, but still the effect of this repeated indicator, this construct using repeated indicator, still the effect of this construct on other criteria are, exist. So it means when we, especially for PLS and mode A and mode B, because when we apply mode A and mode B, relationship between construct influence on parameters. When we calculate the quality parameters for measurement model and also for structural model, right? So when we have second order with repeated indicator, this will affect on latent variable scores and parameters that we get to assess measurement model in first stage, right? So, and we don't actually prevent for these effects. So this is the reason that I prefer, and one of the main effect is actually the high collinearity that this, including this repeated indicator, create and spread in our framework and our model, right? So, but this joint, actually we don't include this repeated indicator second order construct. In this joint, only we connect a dimension of first order with other construct and assess measurement model based on criteria and get the score for second step. But it's only based on my personal experience. There is no any simulation study so far to compare embedded and disjoint to a stage approach. So to actually make sure about difference between these two and show is there any significant differences between these two, or can we can work similarly, some simulation studies should be done.
thank you, Prof. I have one question again related to this. Um, uh, uh, I have. What about the sample size requirements for higher order construct? If we go a bit into more complex models, like including moderator. Okay, well, let's say we have a moderator in a model. We have a, let's say, we assume, let's say we have three independent variables and one dependent and one moderator, and that moderates between all three independent variables and the dependent variable. So how would you, determine the sample size? Would it be automatically calculated by the software, or there are a bit more requirements for it? Thank you.
For calculating by software, by WarpPLS, you can go for these two methods that I already show you for calculating minimum sample size, right? But actually, there is no difference between higher order construct and the first order construct in our framework to calculate minimum sample size. And only one thing can make difference between these between a model with or without second order. For calculating sample size, we have to consider dimensions, not second order, right? Because actually we assess measurement model in first stage, and for assessment of measurement model, we need minimum sample size. So minimum sample size using this solver or these two methods or using G power should be calculated based on predictors, including dimensions in first stage, not in second stage. This is one thing. And second one, if you have moderator, okay, the story is different. If you have moderator, means two groups are compared. Model are compared for model. Actually, we compare model for two groups when we have
gender.
Okay, so when we have male and female, minimum sample size actually should be collected for each group. So it's another criteria we need to consider when we use moderator, when we include moderator, or we want to do multi-group analysis. So minimum sample size should be fulfilled for each group, not in for
Full model.
full data or complete data.
Yes, thank you very much, Prof. Thank you very much.
Okay, no problem. Okay.
Sir, can I ask one question?
Yes.
Okay, I want to ask about the assessment of measurement model. From your demonstration, when you're using higher order construct, it's mean when you want to report, you have to make two assessment of measurement model. The first,
Yes.
when you did not have the link of the construct, and then for the second, when you have a link for the construct and higher order construct, it's true.
You can have link. If you want to use mod A or mod B, you have to have link between construct. But in first stage, we assess dimension of second order with other first orders involved in construct, involved in framework, right? So in first stage, we assess measurement model of all first order construct. Right? In second stage, when we establish second order, we assess measurement model of second order and other first orders involved in framework.
Okay.
Right? Okay. For example, here, for this one, first stage, before creating this second order, you have 3 dimension, right? And 3 IV and 1 DV.
Mhm.
So we have 7 constructs, 7 first order constructs.
With
So
link or not link?
we can see the screen. Sorry to bother you.
You
We
can
can't see
see.
we can't see the screen from your side. I mean the demonstration that you are giving on the software.
What about now?
Yes,
Yeah, we
now
can
now we
see.
can see. Now.
Okay.
Thank you.
So for this framework, for example, you have second order, but in first stage you had 3 dimension, right?
Yep.
So 3 dimension of this second order and 3 independent variable and 1 dependent variable. So in first stage, we had 7 construct, right?
Yep.
So in first stage, we need to assess measurement model of these 7 constructs, not second order. We don't include second order, even when we do repeated indicators or embedded approach. In first stage, we don't include the assessment of second order construct. Only dimensions and other first order. So in first stage, we have 7, right? We have 7 constructs. 3 dimension, and the 3 IV and 1 DB. So this is for first stage. In second stage, when we establish this second order, we have 1 second order. So we have 1 construct here, 3 IV and 1 DB. So assessment of measurement model in second stage should be done for 5 construct, right? 3, 1, 1. So for 5 construct, based on nature of construct, formative or reflective. So for these 4, we have to use criteria for assessment of reflective construct. And for this one, we have to use criteria for assessment of formative construct. And we need to report.
Okay. Okay, it's mean, for example, in the first step, I want to report something like discriminant validity using Forner-Lacker criterion and HTMT, and for the second step, I using STMT or and Forner-Lacker criterion. But for the formative, I made something like a special paragraph for assess for the formative construct, something like that one.
Yes, yes.
Okay, thank you.
For formative, also you can apply, when you have formative, you can apply full collinearity and report full collinearity addition to Forner-Lacker and HTMT, because in the second stage, still you can report the Forner-Lacker and HTMT for this formative construct. But for full collinearity, you can report for all constructs.
Okay, thank you, sir.
Okay. Okay, any other question? How we decide the nature of HOC based on literature? Yes, based on literature review. I would like to ask sample size calculation. Some researchers have said that to develop Monte Carlo simulation to calculate sample size for PLS. This can be one. Actually, the literature recommended different methods or approach to calculate minimum sample size. Some recommended the Monte Carlo simulation, some recommended the G-power, and the most recent literature actually recommended these 2 methods that based on simulation study was tested and recommended by Cork and Hadaya 2018, these 2 methods. If you go to most of recent literature, recent guideline published for PLS, for assessment of model and reporting the result, you can see these two as a recommended method for calculating minimum sample size. So there are different methods you can choose based on. Okay. Any other question? Any other question?
Can you provide the reference for this paper, for calculating the sample size shown by?
Cork and Hadaya 2018.
Can you spell it out?
Sharing. Okay.
Okay, thank you. Thank you. If you can show.
Cork and Hadaya. Okay. You can see my screen. Google Scholar.
Yes, yes.
Okay.
Okay, sure.
So I share here in chat box. This is the paper. But, addition to this paper, you can see many of the guideline papers as a guideline for reporting result of PLS refer to this paper and these two methods.